Here's a code quality experiment. I gave Claude Code the exact same spec twice. Same requirements, same design, same settings. The only thing that changed was the model version. Both outputs passed every single functional test. But when I actually read the code, one of them was noticeably better than the other. Mostly. If you use Anthropic's Sonnet or Opus models, or you've upgraded the models under any coding harness, you've probably wondered, is the code quality actually better with each newer version of the model? I wanted an answer I could point at, so I ran a small controlled experiment, scored the outputs from Anthropic's Opus 4.6 and 4.7 against 13 non-functional code quality dimensions, and then supplemented my judgment with automated static analysis. In the next few minutes, I'll walk you through the setup, the scoreboard, the wins, and the places where the metrics pushed back on my subjective opinion. To make this a fair comparison, I held everything constant except the model. Same coding harness, Claude Code with extra high effort and thinking on, same requirements. A Tetris implementation with AI autoplay functionality, implemented as a single HTML file containing JavaScript and CSS, with no build step. I verified that both outputs passed all my functional tests. What I ended up with was two single-file artifacts doing the same thing. And the question I wanted to investigate was, which one was better written? The simple answer is Opus 4.7 decisively produced better code quality than its predecessor, but not by a landslide. Let's take a look at how it did better. First, it just writes less code to achieve the same functionality. 4.6's output was 2,003 lines total. 4.7's did the same job in 1,800, or about 10% tighter. If you strip to JavaScript only, it's 1,343 lines down to 1,187. Length in single-file code is almost always a proxy for duplication and ceremony. When features match and tests pass, tighter means the model found a more compact way to express the same logic. Second, structural discipline. Both files use section marker comments, but 4.6's structure is superficial. The comment says game logic, and the code still bleeds concerns. 4.7 produces real layering. Constants, then state, then DOM references, then helpers, then the actual logic. The shape of the code mirrors the real dependency graph. It's the difference between commenting your code and organizing it. Third, and this was my favorite finding, variable naming quality. Both models start strong at the top of the file. Both declare nice constants, but deep in the AI evaluation code, 4.6 starts reaching for cryptic abbreviations. TopPen, HGHT, VLLY. 4.7 holds descriptive naming all the way through. Random piece type. Evaluate board detailed. Naming quality correlates with how well a model holds context through long generations. 4.7 remembers the conventions it set up earlier in the file. Fourth, CSS. This one surprised me the most. 4.7 defined CSS custom properties at the root level without being asked. And the knock-on effect showed up in the static analysis. Hex color occurrences in the style sheet dropped by 51%. That's exactly what CSS variables are for. And 4.7 reached for them by default. Fifth, and this is the one that'll matter most if you're reading and reviewing the generated code, async structure. Both outputs schedule autoplay moves asynchronously. Both end up nesting closures. But 4.6 goes 5 levels deep inside a sprawling function. 4.7 hoists the inner logic into a named helper and stops at 2. Fewer pyramids to pattern match. Less eye tracking when you're reading the code. That part's real. But now here's the nuance the subsequent static analysis forced me to add. When I actually ran static analysis, an AST walk in ESLint 9, most of what I'd observed got confirmed. 50% fewer functions over 50 lines, 17% fewer magic number lint warnings, 76% more top-level const declarations. But 3 metrics went the other way. 1. Max nesting depth across the whole file actually went up, 11 levels in 4.6. 15 in 4.7. The named helper refactor I just showed you? It was just a local win. Somewhere else in the file, 4.7 nests deeper than 4.6 did. Pattern wins don't automatically generalize. 2. Cyclomatic complexity got worse on average. Median complexity went from 3 to 4. High complexity functions, anything branching more than 10 ways, went from 8 to 12. 4.7 writes smaller files, but each function branches more. And 3, a small one. 4.7 introduced two uses of double equals where 4.6 had 0. Use strict, and a linter would have caught that. On top of those metric regressions, there are 3 places 4.6 cleanly wins. 1. 4.6 emits use strict, 4.7 quietly dropped it. 2. 4.6 factored local storage access into its own persistence module, with clean load and save functions. 4.7 inlined the same logic with a try-catch that silently fails on error. That's a regression. 3. 4.6 funneled every input handler through a single guard wrapper. 4.7 duplicated the guard clauses inline. More dry debt. The pattern across these 3. 4.6 was better at the extract a small helper to kill duplication move. 4.7 kept related code co-located at the cost of that instinct. If your prompts leaned on 4.6's helper extraction tendencies, you may need to reassert them. Here's what didn't change. Both outputs have around 20 to 25 module scope state variables. Both have a long render function of near 90 lines. Neither reached for classes, modules, or accessibility. The model upgrade did not, on its own, induce better architectural choices. It produced a better factored version of the same architecture. Architectural shape is something your spec drives. The model executes cleanly within the shape you set. It won't spontaneously restructure your system for you. A few honest caveats. N equals 1. This experiment was based on just one spec, one pair of runs, one domain, with JavaScript in a single file. Different specs might shift the balance. With a more structured workflow, design doc, staged prompts, review passes, both outputs would improve, and the gap might narrow or widen. And functional test parity is a floor, not a ceiling. Although both files pass all functional tests, that doesn't mean they're equivalent under edge cases. Here's the practical takeaway. If you're on 4.6 and starting a fresh coding session, the upgrade is worth it. Smaller files, better naming, modern CSS. But keep your style prompts. 4.7 won't restructure your architecture, it occasionally skips the small helper move, and its complexity per function quietly ticks up. It does generate better code, with caveats. The full write-up with the scoring rubric and the static analysis numbers is linked in the description. One more thing before you go. If this experiment was useful, or gave you some new insights about model upgrades, hit like and subscribe. Put your thoughts in the comments so I know what else to experiment on and share. See you in the next video.